Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
All right, so we're going to get started. Welcome. I'm pleased to welcome Lisa Yu today. She did her doctorate at Stevens Institute of Technology, where she worked on using genetic algorithms to understand creativity and support distributed cognition with the crowd. Since then, she went to work with Nikki Couture and Bob Kraut at CMU. She did a 2-year postdoc there, looking at, again, at sort of creativity and distributed cognition across groups of people, looking at using analogy and divergent thinking to help people innovate and do new things that you maybe think you couldn't do on your own. So we're very happy to have you, Lisa. Thank you.
Okay. Okay, thank you, Jimmy. Hello, hello, whenever it's out there. So my name is Lisa. So actually, I want to start a little bit my own history. I did my PhD in the management information system, but I did a lot of projects in psychology, cognitive science in particular. So back then, we were interested in the role of technology in the individual creativity. That is, like, how can we study what's happening here, and then how can we develop technology to support people to solve problem creatively or do task better. But then when we did all the projects trying to design technology, we found that in most cases, actually, when technology like computers, mobile phones involved, it's no longer confined in the single mind. That is, it's distributed. Okay, I can see it here. Across like a small group of people or large group of people. So this idea is called the distributed cognition. Actually has been around for a while. Originally, it was coined in the late 20th. And so the basic idea is that cognition or cognitive process no longer happened in a single mind or confined by whatever you have here. It actually can distribute it to a lot of people. Especially nowadays, we have internet, we have all these web technologies. So it is possible to involve as many people as you want through technology. So one example we are familiar with is open source software development. So in the past, you might have a group of people within a company and to build something together. But now in the new environment, you can involve all these strangers, all these programs. You divide a project into pieces of work, and the people build on each other's code. And another popular example is Wikipedia. So people start to accumulate knowledge in a shared space. So a lot of researchers start to study in these areas, and we have some answers in like how can we distribute this kind of task to many people? How can we allow them to build on each other's work? So we know something in this area. But there's a third area we know less, and there's less study in this area. It's called crowd design. So websites like Innocentive, Threadless, Quirky, or 99 Designs. So in these websites, what people do are slightly different, meaning they are here to do some kind of design, like logo design, or design a T-shirt. Or in Innocentive, people actually try to solve some scientific problem that cannot be solved in a company. And in Quirky, which is a new company, it's even more interesting. It pushes to even further to the crowd, like people can find whatever ideas they think interest and submit their ideas to the website. And all these people help them to select their ideas, develop into product, then they sell the products on the website. So everything is conducted by these people. But so on one hand, all these tasks, they are hard, right? Divide something novel, do this kind of a creative task. It is very hard. We kind of need all these minds to together to do something great. But on the other hand, this task involves a very high uncertainty. Even in the traditional psychology, we are not sure like what's really happening in the mind if you try to solve problems. It's not something you can, like article, you can break it into paragraphs, then sentences, then people just work on these small things. It's like, how can you really break it into design process? How can you control certain parameter to make it creative? Suddenly you have this great idea, you design computer. This kind of things is very uncertainty. So that's why it's hard. That's why I'm personally super interested in this area. So from practical point of view, I'm interested in how can we help people to do more innovative and complex work than they can do on their own. So this kind of work can range from small innovative products, consumer products can be used every day, to very high-tech devices, or even to more fancy, like complex design, like buildings. So by studying this phenomenon happening in this world now, I fundamentally, theoretically, am trying to answer these questions. How can the cognitive process we normally associate with the individual mind can be implemented in a large group of people mediated by technology? Okay, so in the rest of the talk, I'm going to talk about 2 projects I've been working on trying to answer this grand question. And then at the end of it, I'm going to talk about some exciting future research. Okay, so I started from asking the question is like, what's going on in a single mind? Like when people are trying to solve problems, trying to design something, what's the process of this creative thinking? And there are a lot of literature in psychology, and so people trying to study what the creative sparks from. And one of the explanation is called combinatorial creativity. So it argues that actually it's seldom that ideas come from nowhere. Most of the time they are built on the previous ideas. So it is like if you have all these previous ideas, actually new ideas are based on the combination of the creative element of the existing ideas, or you put the previous elements of the ideas in a creative way. So this is what's going on in the individual mind. Then what's happening if you push it too further? Do you distribute it to a lot of people? Like as a human, we have built this culture for thousands of years, right? How did that happen? So there's a lot of words called Memetics. So people study memes. So they treat a unit culture like ideas or certain kind of technology. Unit culture, like they are passed on generation by generation or to different people. So the central process or force in the culture propagation is selection. Like other people have ideas, and the second person might pick on these ideas and use it in a different way. So, so people might have different ideas in this line of work, but the basic idea is selection plays a very big role in culture transfer. So their combination and selection, so we trying to build a process can incorporate these 2 forces, which we call the evolutionary process. So this is how it works. Suppose you have design problems. Then instead of trying to solve coming with ideas yourself, you can post app there to get access to assemble as many people as you want. As a first generation, they can have solutions for you. And then you evaluate them, select the good ones, and match them together into pairs. You present a pair to a second person and ask this person to generate new ideas by combining them. So, and then, so you have this seed ideas, you give us a second group, people build on these ideas, have new ideas, you run this process again and again. So this essentially evolutionary process, like 2 people get married, have kids, and hopefully kids can take the best genes from parents, they become more nicer, or smarter, intelligent. So we are hoping through this evolutionary process driven by combination selection, designs can evolve toward a better, higher quality. So then we need people. We need people to actually carry out this process. And luckily, we got Amazon Mechanical Turk. So we can access as many people as we want. So that's how we get participants. These people have no design background at all. They are like, some of them are stay-home moms, some of them work in construction, or they like distribute in around the world. They work in different professions. And we direct these people to this design interface where they can tap to write their ideas, so they can also draw to realize their ideas. So this is what really happened in the process. So all these ideas were the ones produced by these crowd workers. And so this particular design task was designing a chair for children. So that's why you can see all these little cute features. So they need to consider the material, the attraction to the kid, all these things. And so that you have first generation of chairs, they get being passed on, combined into the second generation and the third generation. So the first question we want to answer is, do designs evolve better later? So we compared the designs in the last generation with the ones in the first generation. And we also want to see whether this process produced better ideas than alternative process. So this alternative process was independent idea generation. We basically mimic what happened in real world, like people generated ideas on their own. So then we need to figure out a way to measure our results. And so in psychology, for the people who study creativity and designs, they basically argue that we need to consider two dimensions when we judge the quality of ideas. The ideas needs to be novel and needs to be practical. If it satisfies these two dimensions, then you can read it in some way and and convert this like a text and images into numeric values, and then compared the quality of ideas. So that's what we did, and that's how we judge the quality of ideas.
So one question, when you say high iterator reliability, was that on previous things that they've done before, or?
Oh, this slide show how we actually rated the ideas. The specific method is.
So in other words, the judges actually did have iterator
reliability
on this.
Yeah.
In the design for the multiple generations, your example versus the one before that, if you could go back to those slides for a second. So here you show something skipping from the first to the third generation.
Mm-hmm.
In the previous one, I thought you limit them. So how do you limit the types of combination that happen in this process?
Oh, you mean how
So you
vice?
show this line that goes from the first to the third generation.
Oh, yeah.
How are people actually constrained in their in what is their starting design and how they can evolve it? Because in the previous slide you showed just limited where each layer can only depend on the previous layer. So I'm trying to understand how complex the process is overall.
Yeah. So when we actually implement the process, we adapted genetic algorithms. So in that algorithms, it has different ways to do this. One is called mutation. It's like you have these ideas, you change in some way, and then moved on to the next generation. And they have this particular process called elitism. Like you would keep some ideas which are rated very high, higher quality, like they are very good. You would move them on to the next generation automatically. And the third process is combination. So you would randomly pair two ideas, but it's more complex than that. You would find two ideas, pair them together, find the ones better ones, and then you find another pair, so you find the better ones. Then you match them up, give it to a person, ask them to generate new ideas. So this process is it kind of favor the ideas with a higher quality. So this process, it basically, it has combination, but it tries to use algorithms to favor the ideas with a higher quality by either increasing their chance of being selected or just moving them directly to the next generation. That's why this idea never, first this example, and even though it didn't get combined here, there's a lot more data. It got combined with other ideas. Second is some ideas is moved because it is considered very good. They are moved directly to the next generation.
So while
the problem about generic algorithm is you need to break your design into several of the genes. And how do you actually break a design into genes? Because it kind of, to me, it's a whole package. It's really difficult to break into several elements and select from them.
Yeah, that's why we think it's great about this research. They in traditional genetic algorithms, they can solve the problems which can be broken into genes, right? But design problems is very hard. As designers, we don't really know what kind of features they should pick and how can we divide this design task into multiple ones. So we basically rely on the crowd to pick the features to decide which genes they should pick, they should use to how they can generate new genes. So what we did, just design this platform, this process, and whatever happened is in the control of the participants. So we later we had a paper analyzing like how the crowd workers pick the genes, the features, and how they actually do the combination. So the basic findings, they favored the parts of the ideas which is practical and novel.
Also, the second question would be, so you probably mentioned this. So how is the evaluation of each generation happens? Is it by some designer or is by the crowd?
Yeah, we did two different ways of evaluating them. First is we found two designers in our architecture design school, asked them to read the ideas based on 2 dimensions. And then we also post all the ideas after Amazon Mechanical Turk to get, I think it's 2,000 Turkers to read all these ideas and calculate whether like the ordinary people, the crowd workers, think consistently with the designers, and we got very high consistency, meaning like because the design task we used is some kind of product everybody understands, like a chairs for children, and so we can try the 2 ways of reading the ideas.
Is there any weighting implemented in each kind of user, or its own or homogeneous weighting? Like, do you weight some users higher as others?
No, we just treat them homogeneous. We did, yeah. Okay. So let's look at the results. So first, we want to know whether we get better ideas through this evolutionary process, and so we tried multiple ways to measure the results. So one way is like count the ideas. So like if an ideas the 2 dimensions are higher above the average scores of all ideas, then it's classified as creative ideas. So there's a binary classification, and we want to know whether the number of the good ideas increased through this process. And that's what this figure shows. Like in the last generation, we got much more creative ideas than the first generation. We also used other ways to count the average quality to see whether on average the ideas improved. We also got a significant difference across generations. So this figure shows in more detail about how ideas evolve. So that the red dots represent ideas in the last generation, the blue circles represent ideas in the first generation. So the 2 axes represent the originality, practicality, 2 dimensions. And you can see the ideas collectively shifted to that corner, meaning they improved on both dimensions. So we also compared the ideas from this process to the ideas generated by greenfield system, meaning independent idea generation, to see whether it produced better ideas. So it shows like through this kind of a process, people are much more likely to generate better ideas than they just do on their own.
How does the greenfield system work?
Oh, just independent. Like I same design problems and ask like same number of people to generate ideas on their own.
But is the number of people for that condition the number of people in the first layer plus the number of people in the third layer?
Oh, yeah, that's a good question. It's very technical. Yes, so we ran for 3 generations. Assume, I don't remember exact number we got, assume we got 500 participants. So in the control condition, we got 500 participants as well. Actually, we also controlled the timing because the generations happens over time. So we actually divided that 500 people into like let's use 300. So the first generation we run 100 at the same time. The second independent another 100. Try to control the timing, so everything trying to happen at the same time.
Yeah, it seems like there's two possibilities. So one is the total number of laborers that are in each condition. The other is, and I think you're referring to this also as the time on task.
Yeah.
In the case that a given design that makes it to the third layer has had n units plus n units plus n units of time, whereas a single pass by even a larger number might only have only the n units of work spent on it, and so you're saying in the Greenfield system you encourage people to work 3 times as long on the task then, or something.
Oh, the timing.
Yeah.
First, in the evolution process, we run it, so there's time lag, right? We run it, suppose we run first generation the first day, second generation second day or second hour, then we run simultaneously, like get a same number of people to do independent edit generation at the same time. But in terms of how long they spend the task, we don't have control over that, because even in the evolution process, some people they spend like a whole hour trying to make it perfect. We actually pay them 5 cents back in 2011. So we cannot like cut it off, like you have to stop at this time. So. Yeah, to see whether people spend a longer time there.
Yeah, whether that results in greater quality compared to the relative total time spent on a task.
Yeah, when we did the analysis, I controlled a lot of variables, including education, design background. And now it happened like 2010. I don't even remember. Maybe I think we controlled it, but I need to double check. Yeah.
It would be interesting to see what the correlation of quality is to time, because it might not actually matter. I mean, the second a fresh set of eyes might make a huge amount more difference than the same person spending more time. So it'd just be interesting to see.
It's a great comment.
So you mentioned quality earlier, but then you're presenting graphs on creativity. What measure of creativity is there? Is there?
So here we basically equal quality with the creativity. So, because we study creativity, we care more. We cannot really put this ideas into manufacture and sell it, right? So we focus on the prototyping step, like ideation. So when we talk about quality, we actually mean creativity. So it means it needs to be novel and we need to be practical.
As rated by these 2 people with high independent rating reliability.
Yeah.
So there's some question as to whether or not they can identify creativity or what creativity means.
Sorry,
So like often, you can go to somebody who, for example, doesn't know the related work well and ask them, is this novel? And they say, yes, that's novel. And you just show it to 30 other people and they go, no, of course that's not novel. This has been done here. So I'm trying to understand, what and how you're measuring it with just 2 people. Can 2 people identify creativity? Has anybody actually looked at this concept of what it means to identify creativity?
Yeah. So that's the question I got most, and that's the question bothers creativity researchers a lot, is how you judge your results, how you measure creativity. And that's also why people never ask how creative this idea is. They're trying to break it into multiple dimensions and make it easier for them to judge it. And that's also why we used both designers and the crowd. We think this is a very good task for the crowd to judge it, because it is something consumer product. People see a lot of chairs for children. If 100 people agree on that it's novel, then it probably means it is novel.
Creativity is judged by how novel the idea is. How is it different from the originality on the horizontal axis?
So basically, being novel is similar being original. People it has to be both original or novel and practical. Actually, there are other dimensions people consider sometimes.
Why are you putting 2 axes like this? To me, it sounds like 2 orthogonal dimensions that you are evaluating this particular design.
Yeah, it has to, idea could be very novel, original, but it could be ridiculously novel, right? It's impossible for us to manufacture, or it's dangerous. So you have to consider the second dimension. Actually, in the later study, we also add more dimensions. Just depends on what design problems we used. We have to consider the context and who are reading them and what the best way to get a overall score to judge the quality. Okay, so this figure just shows what people did. This is design clocks. So that's the two original ideas, and the third person trying to incorporate the features from two ideas and design a new clock. So to sum up, in this process, we are trying to incorporate the force of what's happening in the individual mind and what's happening from a collective perspective, like as a population, how we build culture, and we design a distributed process which can promote the distributed cognition. And the aspect that I'm personally interesting is, so people don't actually talk to each other in person. You have 1,000 people. Once you use images and text, the ideas as a representation for them to build on each other's work, that it can really scale up. But then there's problems. So here you have the first generation at the seed ideas, then you move it to the following generation. It's a converging process. It's trying to integrate it towards to make it better and better. But then actually before that stage, you have to very good seed ideas, right? If the seed ideas are on a very low base, it basically will constrain the following ideas. Then also there in design theories, before you convert to something, you have to explore it, trying to find what might be the alter ways to go, what the best direction to design your ideas. So the next project, we focus on the exploration phase. So if you, in the context, like you just want to generate ideas, how can I help you to do that? So this time we focus on exploration and reusing existing designs. So using the previous designs, again, ideas never seldom happened from scratch. They need to build on the existing designs. That's also why distributed cognition is so interesting, because we have accumulated all these designs, ideas, knowledge in the past, and how can we put people figure out a way to move forward to the future. So there are a lot of examples, but using examples in design process actually is not a novel idea. It happens a lot when people are trying to generate new ideas, solve problems. They would go out there, find some inspirations. But using example, even though it gives you some inspirations, it has a lot of it produces a lot of negative effect. One of the typical ones is called conformity, meaning that your new ideas most time are very similar to the ideas you say. You made some variations, somehow it incorporated the previous features. It kind of reduced the indistinct ideas, reduce the diversity. So the other issue with the example is, especially in the sharing culture, right? Everybody can share their ideas, and there are so many online idea repositories. Then if we can figure out a way to use the example, that would be great. But then all these examples, which one do you choose? I cannot give you 1,000 ideas and say, okay, generate new ideas. So that poses a huge problems with how can we select it and how can we process this information. Again, we can go back to the creativity literature in psychology. Actually, they say there is a pattern between ideas, meaning even though we have all these thousands of ideas, actually a lot of them are similar to each other, meaning it's not like even though in a different field, you don't look like it's similar to each other, they actually share the deep structure, which is called analogy. So I'll give you an example. This is a typical problem used in psychology, is that a general try to conquer this castle, but then there's some roads, there's a mine under the bump. If you have a lot of people walk through it, the soldiers walk through it, it's gonna trigger it, then the people will die. Then how can you conquer this castle? So the strategy here is the general divided an army into multiple forces, and they converge into the castle from multiple directions, then conquer this castle. A different problems in the medical domain is that you have this tumor somewhere, and there's laser can kill the tumor, but it's too strong. If you just how to say it? If you just kill it with a big, strong force of a laser, it's gonna kill the skin surrounding it too. So that strategy is you can divide the laser into different small amount and approach it, the tumor from multiple directions. So these two problems are called analogy. So then you would think, how about we just present people analogical examples, right? So again, it has the problems of conformity. People would, their ideas would affect by those examples directly, the specific features in some way. The other issue is you would be surprised how difficult for people to recognize an analogy. Even you tell them, you show them these two problems, so 50% of people cannot recognize the deep structure similarity. So I'll use an example to show you what I mean by say surface feature. So this is my nephew, and he just turned 1 year old. He's super cute. He's so smart, and he can make noise. He cannot wait to know all about this world. And he spent some time with my mom, and so they really like each other. My mom tried very hard to let him to see the word grandma. So after a month, and he recognize this person I should call grandma. And then he started to recognize some other things. So we would ask him what it is. And he said, a bear. So we showed him another. And he said, grandma. So why is it grandma, not a bear? You've noticed both of them wear a necklace. Both of them are chubby. So as a baby, they start to pick up language. It kind of confound. You cannot recognize the deep similarity between bears, but the surface feature between these two completely different, I guess, objects. So this example show you, like even adults, we are educated, intelligent, but we have huge problems with recognizing the deep structure. We focus on the surface feature. So, but then researchers found that once people recognize the analogy, they actually have, they form some kind of a structure thinking. They call it a schema. I call it schematic thinking. They know that you need the structure. It doesn't matter what the objects are, but it's a shared structure that you are trying to converge and conquer. You divide something, convert it to the center, and conquer the target. So the question we are trying to solve in this project is how to apply the schematic thinking to the crowd. And how can we apply it to the example to design a distributed process. So we have this product, which is from Quirky, that crowd design website. So it's a rake. There is a special slider on top of it. After you click this leaves sometimes stuck on the rake, and you push it down, you can get the leaves off the rake automatically. This is another product that's also from Quirky, invented by two different inventors. So when you do barbecue, you can have these sliders pre-installed in the skewer, and after it is done, you can push it and get rid of all these things on your skewer. So these ideas are very different. They have all these different features. They're in different domains, but they actually share deep structure. So then in this project we are trying to solve is we have all these examples. Some of them share these deep structures, and how can we help the crowd to generate better ideas from them. So the process we design is the first step. We need to create a schema. Schema describe the deep structure. So we show these ideas. So we ask people what the common schema do these ideas share. So for these two, they trying to detach two objects by using a movable slider. So this is how we operationalize the schema. And then we ask people, like, just close your eyes, trying to think, in what other situations might you need to detach two objects from each other? So this set of designers or novice designers, crowd workers, whoever we are focusing on, they don't say the original ideas. We give them these schemas. We ask them to think in what other situations they might have such problems. And then next step, can you solve this problem by using a movable slider? And this is another idea from Quirky. It's when you chop things and all these small things stuck to your knife, the blade of your knife, then you can design clip to attach to your knife, then get rid of it. So there's a completely new ideas, but it shares the structure of the previous two ideas. So this process, I use it to illustrate how we did, how the process should look like. Then we need to test this. First, we need to test the idea that giving people schemas would provoke better ideas than giving them examples. So we get Turkers. We show them either examples or schemas and ask them to generate a new idea. So again, we have this problem how to measure it. So this time we didn't give them design problems. So they generate complete new ideas. They need to figure out their own problems in what domain and solve it, what the ideas should look like. So we add a the second dimension to control the usefulness, because sometimes ideas are novel and practical, but it's trying to solve a very trivial problem. It's not good ideas. So we added this third dimension to judge the overall quality of the idea. So I'm going to walk you through how we run the experiment. So first, we design a control condition to ask people to generate new ideas. They saw 3 ideas, but we didn't ask them explicitly to use it, because we're trying to recreate a real-life situation. When people generate ideas, they just get inspiration, so they don't necessarily use them like in a very explicit way. So, but then we also want to control the timing, the constraints we put on the experiments. This is all the details of experiment design. So we actually ask people to generate new ideas by using example. And the last 2 conditions, we focus on schemas. We ask them to generate an idea by using design rule. So this time we didn't use a schema because we didn't want to introduce new terms to the checkers they didn't understand. So we use it as design rule. So they actually have this schema, and they're trying to generate new ideas by seeing both the example and the structure. So in the last one, we only show them this design rule. So we are interested in what kind of manipulation might help people to generate better ideas. So in the first 2 examples-based conditions, on average, the quality of the idea is 2.5. And in the schemas involved conditions, you can see that on average, we improve the quality of ideas by around 1 point, I guess. So from the regression analysis, we found that showing people schemas can significantly improve the quality of their ideas. But then the next question is, how can we generate schemas? In that condition, in the previous experiment, we as design experimenters, we design schemas. And we also want to make everything can be conducted by the crowd. So we're trying to figure out a way for people to generate schemas. And there were a lot of studies in the past, people trying to make them to summarize the problems or write down the underlying principle or generate their visual representation of the problems. And all of them failed. It is very hard for them to recognize the deep structure of ideas. So, but there's some, in the past literature, there are some approaches worked. One is you show people multiple examples. They are analogies to each other. They share the same deep structure. Then it can help people to realize the commonality in the structure. And the other one worked is showing people constructing example, which is different, which doesn't share the structure similarity. So
the sets are already known? Okay.
Yeah, I'm going to get to that question later. So the set I already know. We want to see in what situations people are more likely to generate the schema. So we controlled the examples we selected. They have to be analogous to each other. So this idea. So it's used to keep your earbuds stable when you walk or run. The second idea is these are all real ideas from Quirky. It's a product about when the dishwasher, the glasses sometimes get broken. They design tether to attach the glasses to the dishwasher thing, so it can be stable. The third one is your head will move around when you sleep on the plane or bus. Is like a strap thing to attach your head to the back of the seat. So it's a very cute product. It's very popular and Quirky. They actually make a lot of money from these products. So they are different products, right? But they share this structure we call the schema. So we also add a different products. This one is like you make the power strip which can change shapes. So it's completely different from the first three. So we will either show people one of them, or two of them, or three of them, the first three, or we replace one of them with the last one to add a contrasting example to see how can people generate the better schemas. And this time we found as you increase the number of analogous examples, people are more likely to recognize the deep structure similarity. They can generate very good schemas. But when you add a contrast examples, and they kind of distracted them from recognizing the schema.
Are they told it's a contrasting example, or are they just shown the set?
No, we didn't tell them. We just showed them the set. Okay, then now we want to close the loop. Remember, my central research goal is to assign tasks to multiple people to design distributed structure. So we're trying to close the loop that to take the schemas generated by the crowd and use it as input to ask another group of people to generate new ideas to see whether maybe the effect we got in the previous experiment because that's something we produced. We want to make everything natural to be conducted by the crowd. So we selected the good and bad schemas from the previous experiment. And we ask people to generate ideas by either, again, observing the examples or using bad schema and examples or using good schema and examples. We want to see whether the quality of schema matters and whether people can generate better ideas by using their colleagues' output. So, and again, this time we found that there was no significant difference observed between the examples of bad schema and examples. But when you show people good schema produced by their coworkers and example, they can produce much better ideas. So these three experiments together composed a distributed process. It suggests that we can break this process starting from examples. A set of people can identify analogous examples. A different set of people can generate schemas for these examples. And the third group of people can generate new domains from these examples. And the last group can generate new ideas in these new domains. We didn't really test every step of it, but we actually ran a 3-step experiment. But it suggests that we can break it into multiple steps to elicit as many ideas as possible and promote the quality. Then now I'm getting back to your first questions. We as experimenter, we select the set of the examples. Then your question may be like, how can people even identify such examples, right? So that's the idea we are working on currently. So we use the crowd to, the first approach we tried is how can we get the crowd out there to find analogous examples. So we show them an idea, show them a schema, tell them go out there, find an idea, share this structure. So they go Quirky, they have thousands of ideas and they trying to find analogous examples. And it worked very well. The accuracy was much higher than they just go out there find examples, the analogous examples. But the question again is like, even though we have these crowd workers, we have thousands of them, it still takes a long time for them to go through a database with like an unlimited number of ideas, right? So we're trying to combine the natural language processing techniques with the crowd, how to efficiently identify the initial set of analogous examples. That's ongoing work. Okay, so to sum up, in this project, we are trying to figure out a new representation of creative content and mine the existing examples to make it as a better source for people to generate new ideas. Also, it suggests a distributed design process. We can go from concrete content to abstract and then go down to the concrete ideas again. So future research. So all my research has been based on the idea of a distributed cognition. And so in distributed cognition, people actually think about mind in two ways. One is you can look for the mind-like property from a large group. Like how can you treat each person as a nuance in your mind, and you make them to actually work in some way to do something great. But the other, like the metaphor can be run in another way around, meaning we can treat the mind as a society of persons. Like each node can function as a person, and they kind of like hundreds of machines and connected in specific ways. And in that way, we can borrow, or the rest of it is my interpretation, is that if you think about it from these two ways, then we can learn from whatever we learned from the mind in society, the groups, the larger group of people, and apply back to the mind to make individual to be more creative, to solve problem better. So along the first line, there are a lot of direction I would like to pursue. One is continue the current work is search for creative content, as I said, like how can we use the crowd, the humans cognition, and the machine learning to find the creative ideas. So currently, if you're trying to design that last ideas I showed you how to detach the garlics off your blade of your knife. Currently, if you search whatever related to that ideas feature, like a knife, cooking, garlic, everything I tried, you would have all these ideas. They're not really helpful for you to solve that problem. But if you search it with that structure, like detach two projects by using sliding object, these are the results I found. I did a test. The middle one is very interesting. It's like a guy trying to ask a girl to pay for everything he purchased. Actually, that's a metaphor way to detach something. You can annoy a girl, but it's not really helpful. So then the goal of this project is how can we actually put in something, search in some way, and get these ideas as a return. So the second idea is, I think I need to go back, sorry, is how can we, so now it's still we need motivation. We need all these crowd inventors, even though in Quirky and Innocentive, they got at least like 340,000 inventors working there. And how can we make designs automatically? When people trying to comment on product, or especially for the unsatisfied consumers, they would say, what's wrong with this product? Then how can we integrate this creative content from customer reviews and automatically reinvent the product? I think that is another direction I'll be interested in work on. So for the second, remember we can think of the mind in terms like a lot of different machines there that you can treat it as a society. Then what does that mean by producing future research? So that's the assumption. We can think individual cognition that way, but it is good if I can actually find some things, because once you make it like a study in a more structured way, you can get internal agencies, internal neurons, internal organizations into coordination with the external structure. That's why I think it might be interesting to study toward that direction. So I'm using example to illustrate what I mean when I say like internal, the society of mind. So this is the work I showed you. I used each design was generated by a crowd member, and they designed these ideas in parallel, and later it integrated into fewer and better ideas. This work was done around 2010. And in the exact same time, Stephen Dunn from Carnegie Mellon University, he was in Stanford back then. He did this work on the topic of parallel prototyping. It says, so basically the funding of that work is that if you ask people to generate multiple ideas at the same time, and later trying to narrow it down to a particular prototype, and you would find that people would take the features, multiple features from the previous multiple versions and generate a final design. They compared it to an iterative process. People just have one single idea, then they keep working on it, get feedback, and generate one final design. And the parallel prototyping led to much better ideas than the iterative process. So at this point, you might note the remarkable similarity between these two work, right? We did it separately. We never coordinate, or he's trying to study a single mind. We are trying to study a distributed mind, but they follow the same thought, like how it works, like the parallel thinking, the divergent thinking. I guess my point by using the example is, if we don't know this work, we only have my previous work, we can actually try to use that perspective to understand and figure something like this. And if I haven't done that, and after reading this work, and we can borrow whatever finding there to apply to the crowd. So that's my future research, is like we can use this kind of thinking to study individuals' mind. And all this, the random thinking, exciting future research, I'm not gonna go through each of them. Future research, always exciting. I'm gonna illustrate a few of them. One is the analogical thinking, to be happy with the crowd, like give them a structure, ask them to generate new ideas. Then how can we apply to the single mind? You know, people sometimes, most of the time, they get stuck to the ideas they have. They cannot think in an alternate way. How can we put them in different contexts and mimic them as a multiple person working at the same times to think of multiple analogies to be able to use the same ideas in a lot of novel ways? The other idea is, so people have trying to figure out, like in Wikipedia or in other kind of communities, peer production communities, how can we get people to contribute to certain content? Like in Wikipedia, a lot of popular topics, so like 1,000 people trying to improve it, but some other areas, nobody ever work on it. But it's the same thing to individuals, right? Sometimes we have tasks we just don't want to work at it. It takes forever for us to get to it. Or when we're trying to solve problems, we just stuck into the particular direction. We cannot think of any other alternate ways. So in the peer production community, there's work done by Minnesota University. They actually design these things called suggest bot. They're trying to reduce the contribution cost, like suggest to you this area is already full, you should work on this area. So it's detect, like use some algorithms to detect the area that need to be working on and suggest like what you should working on. So maybe when we think about the individuals, we can help them to find the thought blend spot. So by doing that, when we figure out what's going on in the mind, what's going on after there, so we can get them both in better coordination, so we can have the real distributed mind can be contributed by individuals and can be built on by others anytime, anywhere, in any way we want. Thanks.
Very interesting talk, thank you. So one of the questions I have about some of your last few slides is that, so you work closely with the design school, and in the discipline of design, one of the things that people are taught is that, so before they go to a design crit, that they have to come up with 3 independent ways to present the same idea. Like it's a very standard kind of procedure. And like in a larger firm, they might split it amongst 3 teams, but like a design student will be trained to be able to come up with 3 independent ideas. And I wonder, because that gets a little bit at some of these questions you're asking, is how do we get people to be better at that kind of independent ideation on their own? Do you know if anybody has kind of looked at, because they go through some training for this, but in the end, are designers then better at do they get less stuck in their own ideas than people who do not have that training? Do you know if anyone's looked at that or?
Well, that sounds exactly like what Stephen Dang has done, right? The parallel prototyping. So that's work they especially focus on advertisement design. Like when it's not designers, real design students with novices. How can you make them to come with multiple ideas, then later on convert to single ideas? It really work, yeah. Hey, Andrew.
Yeah, I have a question about, so it seems like a lot of the examples that you show are focused on design, which is a really appropriate way of using some of these techniques. And so I was wondering if you could speculate on how this might apply to things that are not as practical as design things, like objects like are useful, but more things that are artistic, for example, or like that have certain kind of aesthetic, or even jokes. Like, could you do these kind of processes for producing funny jokes or beautiful paintings and so on? I'm just curious, like, if you could think about like this, how might you apply, or whether you think some of these specifically for things that are practical, or do you think it extends beyond that?
Yeah. So there's it's continuum, right? If there's two main dimensions, one is original novelty, like a lot of creative stuff plays a big role, like a paintings, artistic stuff. The other direction is practical. You can go either way, right? Like the art thing will be in this extreme, and like copy editing will be on this extreme, right? I know it has, so we have been working the consumer product, it worked, and also I know it works in complex problems, like social problems, like in open ideal, people trying to get the crowd to solve social problems, like how can we get people to be more healthy? How can we people to engage in community more? So in that community, they actually tried analogies and it worked very well. So you will notice when people generate a new strategies, they actually trying to borrow metaphors from the other domains. And so these are the two fields works. I'm not sure it's gonna work. I personally think as the random factors, the creativity increases, it will work less and less effectively because there's higher uncertainty, right? Like it's in particular painting, we don't even know how to judge it. Like I don't even understand why Mona Lisa's smile, that particular painting is good. I still don't understand. I went to the Paris, that museum, people say it's good and maybe it's good. So I don't think it's gonna work in that area, but I do think like in between, it depends on how we design the task. You know, there are a lot of studies in artificial intelligence and in psychology, how can we convert the uncertainty into certainty? How can we trigger the random thinking, creative thinking, and by conducting in a more structured way? So I do think it will work in that way. So like even in quirky, some products are very practical. This like a SNAF product, but some other products is kind of a very creative. When you think about it, it's very interesting. So it doesn't matter who we involve in this process, how we design the task, and like we have to figure out what would really need to happen if we design something. Yeah, great.
Related to the fact that designers go to school and they learn, they practice, and they get better over time. And thinking about the kind of improvement that happens in an individual as they go from not being able to design very well to being able to design very well and even better, you know, as they get, you know, more and more experience. What do you think would be the process, or what do you think would happen in the crowdsourcing example? You have these mechanical Turkers that are designing things today.
Yeah.
And now you keep giving them designs. What's going to happen in a few years or a decade from now? Will they be doing better designs in a decade? Or because there's this churn, people maybe aren't getting feedback, will they be doing the same quality of designs in 10 years that they're doing today? Even if the baseline, maybe, you know, they seem to be starting out better. What will happen in 10 years from now?
Yeah. Well, we are talking about the two communities. One community is like a quirky, incentive. They're stable workforce there, right? Inventors, even though they're novices, but they constantly participate in the design process. And the website, their organization actually trying to help people to build these different ways of thinking. I do think from the organization perspective, if they can figure out something to help people to develop skills which can scale up, like design students learn from design school, they can become better over time. But the community, I guess, I have been focusing on, I think it's most interesting is how can we use this transient workers, like one-time workers. They don't really care about making design or achieving complex work as a lifelong profession, right? They are just interested at that moment, I want to participate in this kind of job. Then it matters less about how can we educate or train individuals, and more about how can we design system, like whoever coming in, we can plug them temporarily and conduct this process. That's the job of our researchers to design this system can incorporate transient workers. Any other questions? Yeah. We can talk later.